All right, let's talk about one of the most famous and frankly weirdest ideas in all of science, Schrodinger's cat. It's a thought experiment that really makes you question what reality even is, and it's something that has puzzled the smartest people on the planet for almost 100 years. So let's dive in. So picture this. You've got a sealed steel box. You can't see inside, and inside that box there is a cat. But the cat's not alone in there. Its entire fate, its very life, is tied to the behavior of a single, tiny, unpredictable atom. Now, common sense, your gut, everything tells you it has to be one or the other, right? The cat is either alive or it's dead. But quantum mechanics, the physics that governs the super tiny world of atoms, it suggests a much, much stranger answer. Before we dare to look inside that box, the cat might just be both. Let's see how that's even possible. Okay, so inside the box is this contraption that Schrödinger himself called an infernal device. It's basically a little chain reaction of doom. It all kicks off with one radioactive atom. Now, over the course of an hour, there's a perfect 50-50 shot it will decay. If it does decay, a Geiger counter next to it will pick that up. That triggers a relay, which releases a hammer. The hammer swings down, shatters a little vial of poison, and, well, that's the end for our imaginary cat. But if the atom doesn't decay, nothing happens and the cat is totally fine. Seems straightforward, right? Well, this is where things get weird. To really understand what happens to the cat, we first have to understand the absolutely bizarre rules that that single atom is playing by. We're about to leave the world of our everyday intuition and step into the quantum realm, where things just work differently, in ways that seem to break all the rules. The core concept here, the big idea, is something called superposition, and it's a real mind bender. What it means is that until you actually measure a quantum particle, it doesn't have one single definite state. Instead, it kind of exists in this blurry haze of all its possible states at the very same time. And this slide just nails the difference between our world and the quantum world. You know, a coffee mug can only be in one place. It's either here on the table or it's over there on the counter. It can't be both. But an electron, an atom, they play by different rules. They absolutely can be in many states, in many places, all at once. And look, this isn't just some abstract theory. It's been proven in labs over and over again. You take the famous double slit experiment. You fire a single electron at a wall with two slits in it, and what happens? It acts like it went through both slits at the same time. This both at once thing is just a fundamental, if bizarre, fact of the quantum world. So what happens when we take this proven, very real, but very strange quantum rule and apply it to our poor cat in the box? Well, this is where the thought experiment takes a perfectly logical leap, straight into the absurd. Okay, follow the logic here. If that single radioactive atom is in a superposition of both decayed and not decayed at the same time, then everything connected to it must also be in a superposition. That means the Geiger counter is both triggered and not triggered. The hammer is both fallen and not fallen. The poison is both released and not released. And therefore, until we open that box to check, the cat is logically both dead and alive. Now, if you're thinking this sounds completely ridiculous, you are in great company. The man who came up with it, Erwin Schrödinger, totally agreed with you. He called it burlesque, which is just a fancy 1930s way of saying it's farcical. He's pointing out here that the math of quantum mechanics, the psi function, demands that the cat is this ghostly mix of living and dead, and he thought that was just nuts. And that is the absolute crucial point to remember. This was never a real experiment he wanted to do. It was a challenge. He was basically saying to his fellow physicists, hey, if your theory of superposition is really correct, then it leads to this ridiculous conclusion about a cat. A cat can't be dead and alive, so your theory must be incomplete. But the funny thing is, this paradox he invented to poke holes in the theory actually became a central question for the theory. It forced scientists to really wrestle with huge questions like, what does observation even mean? And where is the line between the weird quantum world and our normal everyday reality? And it led to some pretty wild ideas. So let's look at two of the most famous ways to think about this. First, you have the Copenhagen interpretation. This is the classic view. It says that the moment you observe something, the moment you open the box, that blurry wave of possibilities collapses, and reality is forced to pick one. Poof! The superposition is gone, and you see either a live cat or a dead one. But then, you've got the many worlds interpretation, which sounds like sci-fi but is taken very seriously. It says reality never chooses. When you open the box, the entire universe splits in two. In one universe, you find a live cat, and in another, a perfect copy of you finds a dead cat. Both things happen. So, all this talk about cats and collapsing realities and splitting universes, it might sound like a fun but useless philosophical debate. But here's the punchline. This absurd idea of superposition isn't just a theory. It is the engine that is running our modern technological world. Yeah, the principle of superposition isn't just a paradox, it's an incredibly powerful resource. It's the whole secret behind quantum computers. You see, a normal computer bit is either a 0 or a 1, but a quantum bit, a qubit, can be a 0 and a 1 at the same time. This lets them explore millions of possibilities at once, which could help us solve problems that are basically impossible for even our best supercomputers today. And this isn't just about future tech. The very device you are watching this on right now depends on superposition. The electrons flowing through its silicon chips exist in this massive, shared quantum state. That ability for them to be in multiple states at once is exactly what makes the tiny little switches inside, the transistors, work. No superposition, no smartphones, no laptops, no modern electronics, period. You know, Schrödinger wasn't the only giant of physics who was really bothered by all this. His good friend, Albert Einstein, felt the exact same way. This quote just shows how deeply it troubled them. They believed at a gut level that reality should just be. A cat is alive or it's dead, whether we're looking or not. And yet the quantum world stubbornly and correctly seems to disagree. So while Schrödinger's cat was dreamed up to show how absurd quantum mechanics was, it actually ended up revealing its profound, essential strangeness. It forces us to ask this huge question about our universe. Is reality a solid, fixed thing? Or is it just a blur of probabilities that only snaps into focus when we look? It really leaves you wondering what else out there is just a state of possibility, just waiting for us to open the box.